Hello, everyone. Today, Group 4 will be explaining the applications of optimization of functions of n variables. Group 4 consists of me, Michael, Sakti, Elaine, and Zaki. Here we are going to describe the problem. A company owns an inventory of 100 units of a good. It must sell the entire inventory over the next 3 periods. The profit function for sales within one period is pi x1 equals 50x minus 0.5x squared, with t equals to 1, 2, and 3. It wishes to maximize the present value of profit. V equals pi x1 plus b pi x2 plus b squared pi x3, where b equals 0.8 is its discount factor. Find the optimal values for x1, x2, and x3. Illustrate and discuss the solution. Hint, use the condition x1 plus x2 plus x3 equals 100 to substitute for x3 in the v function and then maximize with respect to x1 and x2. So, step 1 to solve this problem is present given data, substitute pi into the equation. The given data is as follows. The present value of profit is v equals pi x1 plus b pi x2 plus b squared pi x3. The profit function is pi x1 equals v 50 x1 minus 0.5 x squared, t being 1, 2, and 3. As explained before, beta is 0.8 and x1 plus x2 plus x3 equals 100. Therefore, x3 equals 100 minus x1 minus x2. Now, since we've already concluded that the v equals pi x1 plus b pi x2 plus b squared pi x3, we can just then substitute pi into the v equation. So it would be bracket 50x1 minus 0.5 x1 squared bracket plus 0.8 bracket 50x squared x2 minus 0.5 x2 squared bracket plus 0.64 bracket 50x3 minus 0.5 x3 squared. Now, if we were to simplify that, that would be v equals 50x1 minus 0.5 x1 squared plus 40x2 minus 0.4 x2 squared plus 32x3 minus 0.32 x3 squared. I'll then move on and pass it to Sakti.
Okay, now for step 2, we can now sub in the value of x3 and simplify the v equation. So we take the value of x3 that we concluded in step 1, and then we put that into our v equation. It will become v equals 50x1 minus 0.5 x1 squared plus 40x2 minus 0.4 x2 squared plus 32 in bracket 100 minus x1 minus x2 minus 0.32 in bracket 100 minus x1 minus x2 squared. And then we times the 32 and the values inside the first bracket, and we square the values in the second bracket to get the second equation here, which is 50x1 minus 0.5 x1 squared plus 40x2 minus 0.4 x2 squared plus 3200 minus 32 x1 minus 32 x2 minus 0.32 in bracket 1000 minus 200 x1 minus 200 x2 plus 2x1 x2 plus x1 squared plus x2 squared close bracket. And then now we can times the negative 0.32 with the values inside the bracket to get this very long equation, which I think I'll not say every value in it, and then simplify that to make v equals 82x1 plus 72x2 minus 0.64 x1 x2 minus 0.82 x1 squared minus 0.72 x2 squared. And now that we have the simplified equation, we can derive it, which I'll give to Elaine.
So after we simplify the equation v, which we get before, which is 82x1 plus 72x2 minus 0.64x1 x2 minus 0.82x1 square minus 0.72x2 square. We first can derive the x1. So the dou v over dou x1 is equal to 82 minus 0.64 x2 minus 1.64 x1. And we make this partial derivative equal to 0, which then we will get minus 0.64 x2 minus 1.64 x1 equals to minus 82. And now we'll also find the partial derivative of x2. So dou v over dou x2 is equal to 72 minus 0.64 x1 minus 1.44 x2. And we'll do the same thing like we did before. So dou v over dou x2 will be equal to 0. And from then we can know that minus 0.64 x1 minus 1.44 x2 is equal to minus 32. And the next step will be explained by Zaki.
Okay, so now in this fourth step, we can either do elimination or substitution. But for this particular problem, because it is simpler, I'm going to substitute instead of eliminate. So from the previous steps, we get the two equation, which is 82 minus 1.64 x1 minus 0.64 x2 equals to 0, and the second equation, which is 72 minus 1.44 x2 minus 0.64 x1 equals 0. From the first equation, we can get the x1. This is not the real sum of x1, but the equivalent of x1. So we get 1.64 x1. We move it to the, I'm sorry, but we move the minus 0.64 x2 plus 82 to the right. And then we get the x1, which is 0.39 x2 plus 50. Now we substitute the x1 on the second equation with the x1 that we get from the first equation, or what I marked with 3. So 72 minus 1.44 x2 minus 0.64. And in this bracket, we have the equivalent of x1 that I just get from the first equation, which is minus 0.39 x2 plus 50. And after we multiply the 0.64 to the inside of the bracket, we do the operation to the respective variable, constant with constant, and the x2 with x2. And this results in 40 equals to 1.19 x2. And we just divide the 40 to 1.19, and then we get the value of x2 of 33.61. After we get the value of x2, we can substitute it to any of the previous two equations. But for this example, I'm going to substitute it to the first equation. So 82 minus 1.64 x1 minus 0.64, and inside the bracket is the x2 that we have found earlier, which is 33.61 equals to 0. And then we move the 82 to the right side, and we multiply the minus 0.64 to 33.61. And that resulted to minus 1.64 x1 equals to minus 60.487. And after dividing it, we get the value of x1, which is 36.89. As we have learned from the earlier part of the problem, because x1 plus x2 plus x3 is 100. This means that x3 is 100 minus x1 and minus x2. And because we have already found the value of x1 and x2, all we gotta do to find the x3 is just 100 minus 36.89, which is the value of x1, minus 33.61, which is the value of x2. And that resulted to the value of x3, which is 29.5. Now, this is the last thing we gotta do, which is to check that the V is maximum, because in the problem, it is stated that the company wishes to maximize the present value of profit, aka the V. So we can do that with the second derivative. So the second derivative of x1 times the second derivative of dou phi with respect to x2 minus the dou phi with dou x1, x2, or the partial derivative of x1 and x2. And we got the value of 1.952, which is bigger than 0. And we could also look back on the second derivative, which we done previously, because both of them are negative. This proves that the V is maximum at the x1 and x2 and x3, which we have found earlier. x1, which is 36.89, x2, which is 33.61, and x3, which is 29.5. And that's it. We have found the value of x1 and x2 and x3. Thank you very much for listening. Hope you can learn something from this. On behalf of Group 4, thank you very much.